In this video, we'll go over the homework that follows the lecture, in which we discuss how to do calculus with parametric equations, and in particular we focused on integration. So as always, I hope that you watched the lecture, and let's jump right into the homework. And here's the first question. We are given a parametric curve and we have to find the area under the curve. So we would assume under implies between the curve and the x-axis. And to find this area, normally we would just integrate the function, but we have a different formula for finding the area of a curve defined parametrically. That is, we're going to be integrating from some values of alpha and beta, which are determined by the domain of t. And what we're integrating here is the f prime of t dt. And to see where this formula comes from, you would probably want to watch the lecture. And let's just check something real quick here. Forgot it. I guess I forgot the formula myself here. So the formula is actually, can't believe I forgot it. The formula, here's the formula, right? Here we have f of x, but we think of f of x as y. So y isn't going anywhere. So the only thing that we need to handle here is dx, and dx can be rewritten as x prime of t dt. So this is the formula. So the old formula converts into the new formula like this. And in our case, the limits of integral are from 0.3 to 0.8, and y of t is 3 e to the power 2t, and x prime is 42 e to the power 6t dt. So it's a rather simple integral. So we have uh, 126 e to the power 8t dt. The antiderivative will be 1/8 e to the power 8t, and we evaluate it from 0.3 to 0.8. And I certainly not looking forward to evaluating this by hand, but if I had to, this is what I would do. And I would put this in Desmos. And that's the answer. However, now that I'm here, why not just enter the whole integral? And now we see that this is really the right answer, and we have more confidence before submitting this over here. And we have to round to the nearest hundred, so that's fine. So that's the answer. Next question. We have surface area question. And for the surface area, again, this is where you look for all the formulas in the lecture. So for example, this is this formula. And here you just need to understand what is ds stands for. ds is the expression that we used when computing the arc length. So ds, when dealing with parametric curves, can be expressed in two different ways. You can express ds, actually I apologize, ds can only be expressed one way. It's going to be x prime of t squared plus y prime of t squared dt. And what is r? R is the radius of rotation. So if you rotate around the y-axis, then r is x, and if you're rotating around the x-axis, then r is y. So this is the formula and this is how to use it. So let's go back to our problem and let's find the surface area. First, we're going to set up the integral. Our integral will be, what are we doing here? We're rotating around the x-axis. So when you rotate around the x-axis, your radius of rotation is this, which is y. So integral is from 0 to 1 of y of t I guess let me write it in general form first. It's going to be the integral from alpha to beta. It's going to be y of t. Also missing 2 pi. I need to stick it somewhere there. So might as well, we can put it outside. And here we put ds, but ds is going to be this. So this is the setup, and now we have to find everything one step at a time. So what's x prime of t? It's negative 6t plus 2. What is y prime of t? It's 6t squared plus 2t plus 3. Now we're gonna square it and add it. And nowhere it says I have to do it by hand. So I'm literally going to input into the calculator the following. And let's see what it's equal to. We got 2 pi integral from 0 to 1, 2t cubed plus t squared plus 3t plus 1 square root. And here I'm tempted to use technology to its fullest potential here, and why don't we define x of t to be what it is, right? So x of t is negative 3t squared, negative 3t squared. Actually, I don't know, 2t squared plus 2t plus 1. Would it find x prime of t? Actually, it doesn't like it. So we can define, yeah, it's okay. Let's just get it done. So negative 6t plus 2 squared plus 6t squared plus 2t plus 3 squared, all that with respect to t, and that's the answer. So approximately the answer will be 157,903. $157,903. Oh, 90. So we are going to use this formula, 2 pi integral of r ds, and ds in this case is the square root of x prime of t squared plus y prime of t squared dt, and we're going to find x prime of t. It's going to be 18 sine of 3t, and we're going to find y prime of t is going to be negative 18 cosine of 3t, and we're going to set it up as an integral from negative pi over 3 to 0. We have 2 pi here. We have r, because we're rotating around it doesn't tell us how we rotate it, so we have to graph it to see the rotation. We have negative 6 cosine of 3t, comma, negative 6 sine of 3t, and t goes from negative pi over 3 to 0. So it must be rotated around the x-axis, right? Otherwise, you're not going to get a sphere, you'll get a semisphere. So it's rotated around the x-axis. That means the radius is equal to the y, and y is negative 6 sine of 3t, and we multiply by the square root of x prime t squared, so it's going to be 18 sine of 3t squared plus 18 negative 18 cosine of 3t squared dt. Now, by Pythagorean identity, this whole thing just becomes 18, and this integral should be easy to compute. We're going to get 2 pi integral from negative pi over 3 to 0 of, we have negative 6 times 18, it's negative 108 of sine of 3t dt. So the answer will be 2 pi negative 108 divided by 3. We're going to get negative cosine of 3t from negative pi over 3 to 0. We get 72 pi cosine of 0 minus cosine of negative pi over 3. Cosine of negative pi over 3 is 1/2. So negative 1/2 though. So we get negative 36 pi, but I think negative here, it's the, it just means we choose the wrong direction here. So we should have integrated from 0 to negative pi over 3 instead of negative pi over 3. There is such a thing as positive and negative direction. So I think here it will be fair for us to take the absolute value. But, so I'm not concerned with the sign, but we're going to check all the work here. First thing, I'm going to check my integral. We integrated from negative pi over 3 to 0. And we integrated negative 108 of sine of 3t dt. And what's 108 over 3? That's 36 times 2, 72. What's cosine of pi over 3? I think I'm, oh my god, I'm like terrible with my trigonometry here. Cosine of 0 is 1. Cosine of negative pi over 3 is 1/2. So this is going to be 36 pi. Anyway, why am I not getting the 2 pi thing? So the whole integral will be, according to Desmos, it's 144 pi. Where is the... Oh my god, I see. This is not, I'm not doing it correctly here. Well, this is what Desmos is for, to check the work. So cosine of 0, this is cosine of negative 1 actually, negative pi. And cosine of negative pi is negative 1. right? And here we get 144 pi. So this is the right answer, right? 144 pi. Now I'm pretty sure of that. But what do we enter here? I don't know. I guess 2 pi here. Negative pi over 3 here. 0 here. Negative 108 sine of 3t here, and all that is equal to 144 pi. I think that's what they want. Let's check, and that's right. This was question number 3. Question number 4. Looking for the arc length. The formula for the arc length is this, where ds is just the square root of x prime of t squared plus y prime of t squared dt. And in our case, it will be integral from 0 to pi over 2 square root. What's x prime? It's 12 sine of 6t squared plus 2 cosine, negative 2 cosine of 2t squared. Dt. And it doesn't ask us to find it, it only asks us to enter the integral, so we can do that easily. That was pretty straightforward. And now we are asked to find the arc length. So we're now going to use the formula. We have an integral from alpha to beta, square root of x prime of t squared plus y prime of t squared dt. So x prime of t is negative 1 over 2 square root of 2t times 2. So we can reduce it. Y prime of t will be 7 over 2 square root of 7t times another 7. So it's 49 over 2 square root of 7t. Now we're going to find x prime of t squared is just 1 over 2t. We're going to find y prime of t squared is just going to be 49 squared over 4 times 7t. So it's going to be, looks like 343 over 4t. And we're going now to find the square root of x prime of t squared plus y prime of t squared. It will be the square root of 1 over 2t plus 343 over 4t. So it's going to be 345 over 4t. And the arc length will be the integral from 1 to 2 of square root of 345 over 4t, and it may look scary, but it's not. All you have to do is just take out square root of 345 and this is all you have left. So it will be square root of t evaluated between 1 and 2. So square root of 345 times square root of 2 minus 1. And I guess they didn't ask us to do it by hand, although it's a good practice. So let's check the answer before we plug it in. We have 2 pi. Oh no, sorry, we don't have 2 pi. We have integral from 1 to 2 of square root of (345) divided by 4t. And let's just check if we did it correctly. Yep, we did it correctly. So approximately the answer is 7.69. Next one. So the area, to find the area, we're going to use this formula. Normally it's y dx, but for parametric curves it's this way. So we're going to integrate from pi over 12 to pi over 4. We're going to integrate y, and derivative of x is 24 cosine of 6t dt, and this is a simple trigonometric integral. So we have 168 of cosine squared 6t dt. So we're going to use reducing the power identity here. Cosine squared 6t, cosine squared theta in general can be written as let me think. It is it's 1 plus cosine of 2 theta over 2. And we're going to have now 84 integral from pi over 12 to pi over 4 of 1 plus cosine of 12t dt. And now this is easy, right? So this is just t plus 1 12 sine of 12t from pi over 12 to pi over 4. So we have pi over 4 plus 1/12 sine of 3 pi, that's just 0, minus pi over 12 minus 1/12 sine of pi, which is also just 0. So at the end we have 84 pi over 4 minus pi over 12. So this is 0. This is 0. Pi over 4 minus pi over 12. It's 3 pi over 12 minus pi over 12. It's 2 pi over 12. So it's pi over 6. And 84 is divisible by 6. So it looks like it's just 14 pi. So this was question number 6. Number 7. To find the arc length, we're going to set up this integral from 0.6 to 1.2 of square root of the derivative of x squared. So it's going to be negative 2 e to the negative 2t. Let's do it in steps. Don't wanna clutter the page here, so let's find derivative of x first. It's going to be negative 2 e to the power negative 2t times negative 2. So it's 4 e to the power negative 2t. What is the derivative squared? And I guess here we're going to be putting it into computer anyway, so it doesn't matter. What's the derivative of y? It's going to be 3 e to the negative 3t times negative 3. So it's going to be negative 9 e to the power negative 3t. So the arc length will be the integral from 0.6 to 1.2 of square root of 4 e to the negative 2t squared plus negative 9 e to the negative 3t squared. All that dt. So let's put it in Desmos, just like that. And that's the answer. This was question number 7. Guess could have done it by hand, but that's not the point of this problem set. Here we're doing what? Another arc length. So let's set up the arc length. So we're gonna find x prime of t. X prime of t will be 6 times 1 over 2 square root of 6t times 6. So it's 18 over square root of 6t. X prime of t squared will be, again, we only asked to set up the integral, so we're not asked to solve it. So let's not do more than what we asked. So derivative of y is 5 times 1 over 2 square root of 8t minus 5 times 8. So it's going to be 20 over square root of 8t minus 5. And now the integral will be square root from integral from 1 to 2 of a square root of 18 over square root of 6t squared plus 20 over square root of 8t minus 5 squared dt. So that's the integral. We can make it a little simpler, and I'll try, but don't know if it's going to work. So we have, what's 18 squared? I don't know, so I'll just leave it like that. But in the denominator, when you square the radical, it just becomes 6t. What's 20 squared? I don't know. But in the denominator, we just have 8t minus 5. Let's see if they did it by hand. Actually, there's nothing to do by hand, right? So all right, almost halfway through. What we have here is surface area. And the formula for the surface area is 2 pi integral RDS from alpha to beta. And we're rotating around the x-axis, so r is y of t, and ds is, as always, for parametric curves, will be this. And we just need to find x prime of t, which is -3, and y prime of t, which is just 1. So x prime of t squared is 9, y prime of t squared is still 1. So ds will be equal to the square root of 9 plus 1 dt, which is just square root of 10 dt. However, we're not asked to compute anything here. We only have to enter the integral. So we have 2 pi integral from 1 to 3. And we're integrating the y function, which is t plus 6 times this radical. So it's going to be square root of 10. Let's go to the next question. Not sure what happened to Zoom here. Have another area of a surface. Same formula. 2 pi integral from alpha to beta of r ds. R in this case is y of t. ds is again x prime of t squared plus y prime of t squared dt. So x prime of t is 1 over 2 square root of 4t times 4. So it's 2 over square root of 4t. So x prime of t squared will be 4 over 4t. So it's just 1 over t. Y prime of t is going to be 24t squared. So y prime of t squared is going to be 24 squared t to the 4. And to set up this integral, we're going to write 2 pi. The limits are from 3 to 4. And we're integrating the square root. We're integrating y of t, which is 8t cubed, times the square root of derivative of x squared plus derivative of y squared. That should be the setup. We setting up the integral to find the area under the curve. The area will be the integral from alpha to beta of y times x prime of t dt. So in our case, it's going to be from pi over 12 to pi over 4. Y is negative 6 cosine of 6t, and x prime is negative 7 sine of 7t. All that dt. And pi over 12, pi over 4, 42 cosine of 6t, times sine of 7t. Now we have to find the area. So just like before, we're going to set up the integral from alpha to beta of y of t times x prime of t dt. So in our case, we have integral from 5 to 6. Y of t is 10t minus 7. And x prime of t is just 1. So the answer is 5t squared minus 7t from 5 to 6. 5 times 6 squared minus 7 times 6 minus 5 times 5 squared plus 7 times 5. I'm just going to do mental math because I don't have a calculator here. 5 times, I'm going to combine this and this. Take out 5 and we have 6 squared minus 5 squared. It's going to be 6 minus 5 times 6 plus 5. And now I'm going to combine these two. So it's going to be 7 times 6 minus 5. So the final answer is 55 minus 7, which is 48. Hopefully I didn't make a mistake. And let's move on. Same thing, setting up the integral from alpha to beta of y x prime dt. So it's going to be integral from 2 to 4 of y times x prime dt. 2's are gone. Here we don't have to do it by hand, so I'd rather not. So the answer is roughly 19.5455. One more. We're doing area under the curve. Derivative of x is negative 10 sine of 5t dt. So we go from 0 to we have 70 sine of 5t times sine of 5t. And that should do it. And that wasn't good enough. We are stuck at 99% mastery here. So not sure how I feel about that. Find another area under the curve. Derivative of x is 2. And we have 2 times, let's just integrate it real quick. So we have t squared minus 4t from 3 to 8. So we have 8 squared minus 4 times 8 minus 3 squared plus 4 times 3. Mental math. Difference of squares, 5 times 11. So 55 minus 20, that's 35. And that was good enough. All right, if you have any questions about how to do problems involving integration with parametric curves, please let me know.